Hey, all you cool cats and kittens out there. It's time for more chemistry. And we can't start out a chemistry lecture without an awesome chemistry joke. So here's one for you. And this is kind of fitting considering we're in distance learning. Why should you go to a chemist for your problems? Because they have all the solutions. Okay, so now, after that amazing joke, we're going to learn about something called molar volume. And so with gases, they're usually in liters, and you can't really measure them by going and like putting them on the scale in the, in the lab or whatever, because they're a gas and they're super far apart and they take up a really big volume. So we're going to learn 3 different types of ways to work with gases. We're going to start with our first video on how to do something called molar volume. So how is molar volume used to determine the volume used or needed in chemical reactions? So we're going to start with, what is molar volume? So in chemistry, we work with something called STP, standard temperature and pressure. So standard temperature and pressure is when you are at 1 atmosphere and 0 degrees Celsius. So if the pressure is exactly 1 atmosphere and the temperature is 0 degrees Celsius, 1 mole of any gas, doesn't matter what kind it is, 1 mole of any gas, everyone is the same, is going to occupy exactly 22.4 liters. Since if you're at STP, we can go between moles and liters, we can use that as a conversion factor for doing problems. So here's an example of a question. What volume will 5.8 moles of nitrogen gas occupy at STP? So we're at STP. So when we're at STP, we can use this as a conversion factor, just like we've been doing this whole time. Anytime you do a conversion, you start by writing down the number and the unit of what you have. So we have 5.8 moles of nitrogen gas. So nitrogen, and nitrogen is one of those diatomics, so I'm just going to label it like that. That's our starting substance. We want to get to liters. If we're at STP, 1 mole is equal to 22.4 liters. So we can set up our conversion factor. Whatever unit you're starting with, it hasn't changed, it never will change. Whatever unit you're starting with automatically kicks down and goes into the denominator of our conversion factor. What you're trying to get to, we want volume, is always going to go on top. And then our numbers come from our equal statement. So we know that 1 mole is the equivalent of 22.4 liters. Moles of N2 canceled out with moles, which leaves us with liters. And now it's a matter of plugging and chugging. And when we're doing conversions, it's not a cross multiply. You're multiplying by a fraction. So you think about the top being multiplied together, the bottom, and then the numerator divided by the denominator. So in this case, we've got all ones on the bottom, so they're not going to make any difference at all with your calculator. So in your calculator, you're going to plug in 5.8 times 22.4, and then hit plug and chug, and you should get 129.92 liters. So you can do this anytime a problem states that you're at STP and you want to convert between volume and moles. But a lot of times in the lab, we're usually doing some type of reaction. And so we need to know how to go between not just moles and volume, but also mass and volume. And we know how to convert between mass and moles. So if we want to go between mass and liters, what we're going to do is we're going to always first convert to moles. So first go to the mole. And hopefully by now you've realized that that's how chemistry is. Almost always, for every type of problem, at some point we're going to convert to moles. And then once we can convert to moles, then we can go to what we need to do. So we're going to first go to moles and then use that STP molar volume. The 1 mole equals 22.4 liters. So as long as you're at STP, you can use that conversion to go between moles and liters. If you're in grams, you need to first convert to moles. So if you remember, the way that we go to grams, or the way we go to moles from grams, is we have to find the molar mass of the substance first. So this will be a good little review for you. Molar mass is by taking the masses of the individual elements on the periodic table and adding them together. So if I look at the formula H2O, I have 2 hydrogens and only 1 oxygen. So I take however many I have and I multiply that by the molar mass, which is the decimal number found on the periodic table. And for consistency, this whole time we've always been saying to round to 2 decimal spots. So if I find hydrogen on my periodic table and I round to 2 decimal spots, I'm going to see that it has a molar mass of 1.01. So if I take 2 times 1.01, that's going to be 2.02. That is my molar mass for hydrogen. To that, I need to add the oxygen. Oxygen is like 15.9999. So if we round that to 2 decimal spots, we've been saying this whole time that you can just use 16 for oxygen. And then to get molar mass, we said what you do is you add them together. So the molar mass of water is going to be 18.02. So that's my molar mass. So my first step is to get from mass to moles. And the way I do that is I take the 40 grams of the water, just like we've been doing since November-ish, and I set up my conversion factor to go from mass to moles. So remember, molar mass is how many grams are in each mole. So we said that we could set that up like a conversion factor. Grams per mole. And we said it's always going to be 1 mole with the molar mass. So your number always goes with grams. And so we're going to go ahead and plug and chug that out into our calculator, because grams of water cancel with grams. We're going to be left with moles of water. And if we plug and chug that out to 2 decimal spots, we're going to have 2.22 moles of water. Now that we know how many moles we have and we're at STP, we can use that 1 mole equals 22.4 liter conversion factor to get us to the liters. So I'm going to start with my 2.22 moles of H2O, and I'm going to put that over 1 because that's how we always start every single one. And now I'm going to set up my conversion factor. Whatever I start with always goes in the bottom. So moles is going to go on the bottom. What I'm trying to get to always goes on top. I'm trying to get to liters. And then my numbers come from my equal statements. So 22.4 liters for every mole. Moles of water cancels with moles of water. And now I go ahead and I plug and chug that out into my calculator. So it's going to be 2.22 times 22.4, which is going to give me 49.73 liters. Now you could have done this all as one big problem. So if you can see that, go ahead. Like you could have set this up instead. Excuse me, my pen just kind of blurted out here. You could have set this up as 40 grams over 1 times 1 mole over 18.02 grams times 22.4 liters over 1 mole. You could have done that and you would have came up with the same thing, which would have been 49.73 liters. But you can also do it into steps. So whichever method you want to use, completely up to you, whatever makes more sense to you. Some people get freaked out when there's more than one conversion factor in a roll. So if that freaks you out, then do it in 2 steps. If it doesn't freak you out, you can just do it all as one big step. I'm going to show you a shortcut next. So let's say you're at STP and you are given liters and you want to solve for liters. There is a shortcut that you can use, but you can only use it when you are at STP and you're going from liters to liters. That's the only time it works. But it cuts out a bunch of extra conversion factors that are just going to end up canceling each other out anyways. And so this is a shortcut I want to walk you through. So here we have a question where I've got liters of oxygen. Nope, I've got liters of hydrogen. I'm at STP, so you can only use a shortcut when you're at STP. And I've got liters and I'm going to liters. So the only time you can do this is when you're going from liters to liters and you're at STP. So this is a shortcut. When you have this situation, all you have to do is take your starting liters and multiply it by the mole ratio to get your answer. So my starting volume is 6.7 liters of hydrogen. And instead of having to go through the whole process of going from liters to moles and then mole ratio and all that stuff, I'm just going to go from liters of one thing to liters of another using the mole ratio. So if you remember, mole ratio refers to those whole number coefficients that are in front, and there's not a 1 here, so I'm just going to draw it on, in front of your substance. Those are your mole ratios. And just like before, we take whatever we're starting with and we put it on the bottom. And whatever we're trying to get to, oxygen in this case, is going to go on top. And then our mole ratio are those whole numbers. So there's a 1 in front of O2, so I'm going to put a 1 here. And there's a 2 in front of H2, so I'm going to put a 2 here. This whole thing right here, that is called a mole ratio. So we've talked about that in the past, but we're just going to review it quickly right now. So if I want to go from liters to liters, and I'm at STP, all I have to do is multiply my beginning liters right here by the mole ratio, and I can cut out a bunch of steps in between. So that's a shortcut that you can use. So I'm going to end up with hydrogen canceling out. I'm going to get liters of O2, and it's going to be 6.7 times 1 divided by 1 times 2, or 6.7 divided by 2. So if I plug and chug that in my calculator, I'm going to get 3.35 liters of oxygen. Okay, so that's it on molar volume. You now have enough information. You could go ahead and do that first section on different types of gas stoichiometry problems. I went ahead and separated this into 3 different videos because there are 3 different types of gas calculations when it comes to like stoichiometry stuff. And so you can watch this video and then go do the first part of it, then go watch the second video, do the second part, go watch the third video, and so on, as a way to break it up to keep it fresh in your mind. That's it for now. I'll see you soon. Well, hear you soon. Haha. Have a good rest of your day. Bye-bye.